So when we first started networking, we saw the OSI module. We said that we have 7 layers. We have layer 7, which is the application layer. We have layer 6, which is the presentation layer. So if you go back in the previous videos, you see it. Layer 5, which is the session. Layer 4, which is the transport layer. We have layer 3, which is the network layer. We have layer 2, which is the data link layer. And we have layer 1, which is the physical layer. Now, the physical layer, we said, is where the cables and the network, the signal and all that falls. Which is layer 1. Layer 2 is where we are now, the data link layer. This is where your switch is. So your switch is a layer 2 device. Basically, any information at layer 2, so any information that goes to a switch into our PC is referred to as an Ethernet frame. So any information, any data that goes to our switch is called an Ethernet frame. And so technically, when we talk about internet frames, Ethernet, not internet, Ethernet frames. So Ethernet, we're saying that they are at layer 2 and they have, it's like an envelope which has the data, the actual data. But anytime you have an envelope and you have a letter you want to send to someone, first of all, you have to address the letter. And so as part of the letter, this is the letter we send in. But the letter comes with some address and some additional information, maybe a stamp and all those things. And these other extra information is what the stamp and all those extra information are. I'm going to explain each of them one after the other briefly, and then we'll make some progress. The first one is what we call the preamble. The preamble part of your data frame is just like is a delimiter. It's like a marker that tells you that this is more like the beginning of your data packet. It's telling you that maybe this is the beginning of your data. Or it's telling you that, okay, one data has finished and this is the beginning of another part. Apart from that, the next thing is what we call the destination address. So when you say destination address, previously in a previous session, we saw that assuming somebody wants to send information to somebody, if they are connected on the same switch, there's a process called ARP, Address Resolution Protocol. So let's say this is 10.1 and this is 10.2. Switches will not send the information based on the IP address. Switches will send information based on the MAC address. And so once you receive the information, that what the switch will do is that the switch will ask this guy, hey, I know you are 10.1. What is your MAC address, which is the physical address of the device? Maybe this is AA. So this one will say AA. And so the switch will keep a record of this and say that, okay, anytime anybody wants to go to 10.1, 10.1 is AA. Now, because this guy wanted to communicate with 10.2, the switch will send information out all the other ports, asking who is 10.2. The only person that will reply is 10.2. And when 10.2 is replying, 10.2 will be replying with its MAC address. And so the switch will be forwarding information. And then when you receive it, it will learn that information. You say, okay, now I know who is 10.2. 10.2 is also having a MAC address of BB. Now, this information, because we wanted to go to this destination, this information here is just the MAC address of this guy, the BB. Now, the source is whoever was sending the information. So this is, in this case, this is going to be AA. So BB for who is sending it, AA for, I'm not saying this is going to always be that. So BB is just, I'm just using it because I'm saying this is BB. AA because I'm just saying that the MAC address here is AA. And so this one, the destination is just telling you that this is where we want to, the MAC address of the device we're sending it to. And AA is telling you that, I mean, this is the source. So basically, in our data frame, what you see is this. I'm not going to go into the preamble and all that, but let's assume that we're forgetting about the preamble. It's just maybe something. So this is going to be like BB, which is the destination address. And this is going to be AA, where the information is coming from. Now, once it does this, the type is going to tell you what protocol that are we sending to, what protocol or what kind of information are we sending to the person that we want to send information to. And so that's what the type is. And then the actual information we send in is here, the data. And then the last part is what we call FCS. Sometimes it's called CRC. So FCS, which is frame check sequence, or CRC, which is also called cyclical, forgive my spelling, cyclical redundancy check. The cyclical redundancy check, I'm not going to go into the details, but cyclical redundancy check is just that part of your information that will check whether the information you send in is accurate. When I say accurate, has the information been, any part of the information been lost? If any part of the information has been lost, this is the guy that will know about it. Because basically, when you have the information, the frequencies checksum will generate a code or something and will put it in the envelope as part of your information. And so when the person receives the data, if something happened along the line, the FCS, which is generated based on the information that we're sending, and the FCS, when the person who receives the information, the machine will also do its own checks. They will see that they don't match because something has happened. So the information has changed. There's an error. Some part of the data has dropped. So because of that, the information will not match. And so FCS is an important component because it's just like saying, I'm taking a picture of the information I'm sending to you. Once you receive it, you look at the picture and then you compare the picture with a picture you also take when you receive the goods. And if they are not the same, you realize that there's been an error somewhere. And so that's the job of FCS.